Recording of R. James Benner of 405 Harper's Way, Lansing, Michigan 48917. Jim's phone number is area code 517-323-3597. The recording was made by Jim Walkinshaw of the Oldsmobile History Center at the History Center at 4000 North Grand River on October 11th, 1990. This is tape number 1 of 2 tapes. Okay, Jim, if I can just start you with your name, your address, and your phone number, if you would, please.
I am Jim Benner. I live at 405 Harper's Way in Lansing, 48917. My phone number is 517-323-3597.
Great. Now, if you would just take us back to when you started and what you were doing.
Well, I started as a tech student, a GMI student, in October of 1951. Roomed at Lansing with a fellow named Jim Walkinshaw, 313 William Street. Remember that address?
And a few other guys.
Yeah.
Who all were there, was it?
And Roger something or other, Bob Jonkier, the guy from Belgium. Remember him? He ended up with a French Atomic Energy Commission or something.
Yeah.
I forget, Jack Baker for a while.
Jack Baker.
But anyhow, those were good days, and graduated at the 4-year program in August, I guess it was, of 1955.
In what? What was your degree?
Oh, Bachelor of Mechanical Engineering. And for the last 2 years of the GMI experience, I guess it was really more than 2 years, more like 2.5, I co-opted with the product engineering department.
Right.
And had a particular fondness for engines. In fact, during that time, I kind of set as a goal to at one time or another be completely in charge of the design of Oldsmobile engines, which I was fortunate enough to arrive at later on. But when I graduated, I was assigned to the lab. I was called a detail project engineer. Worked in the test lab, product engineering department, and wrote my thesis on the installation of a chassis dynamometer, which is the first one we had there. And a year later, of course, I received my degree. I guess I told you I had my degree at the end of 4 years. That's not right. Get it at 5 years. Then so that was fun. We worked in the lab testing components.
Was that kind of traditional for GMI guys?
Yeah, it was traditional for any new hire.
Okay.
Unless you were going to be a designer and work on the board, you were assigned to the lab testing components. That was fun. You think back in those days, that was a lot of fun.
During your GMI experience there in product, did they bounce you around to all the groups and?
Oh yeah, yeah. I worked in the lab some then. Worked with development engineers, with test engineers, quite a little bit on the drawing board, and mostly because I made such a fuss about wanting to work on engines. That's what they gave me most of the time. So there was, I don't know to what extent a fellow can do that today, but in those days, if you really expressed a particular interest in something, why management was able to let you experience
Do you remember
that
who some of the guys in the
line
department
of work.
that were in those days?
Oh yeah, Harold Metzel was chief engineer,
Okay.
and Lowell Koenig, I think Metzel's still living too,
Yes, he is. He's in
in
Arizona.
Sun City.
Yeah.
Lowell Koenig, now deceased, was assistant chief. John Belts was quite powerful in the organization. He ran the experimental department.
Mm-hmm.
It was interesting because when I retired, that's what I did.
Mm-hmm.
The world is round.
Yes.
But that was the old gang, and that gang was pretty much, well, and Gilbert Burrow ran the engine group.
Okay.
He was motor engineer. And that gang was pretty much there through, oh boy, as near as I can recall, early 60s to mid 60s.
Mm-hmm.
That was kind of the gang that,
Mm-hmm.
that I worked with. And remember Charlie Hagan ran the drafting room at that time, and I remember Charlie because he taught me a lot about engine design, just logistics of
Mm-hmm.
of engine design. I remember one time he wanted me to design a water outlet gasket. You know, big.
Tough
Boy,
job.
this was really great. This is wonderful. So I proceeded to sit down and design the greatest water outlet gasket there ever was, and I got all done. And Chuck said he took out last year's drawing. I guess this one had to have some little tiny change on it over last year's type. And he says, well, you made it altogether different than last year's type. I said, well, of course, this is my design, you know. And I got mad because he wanted me to make a bunch of changes in it, which made it just like last year's, except for some simple little thing that had to be. So I learned a lesson in life at that time. You just don't start over from ground one and waste all that tool money, when an easier way is to make a modification to an existing part and rework a tool.
Reinvent the wheel.
Yeah, so, but I was really blown out of the tub on that, but it was a learning experience. Funny how some of those things stick in your head. Well then, see, where was I?
So you were down in the lab.
Yeah, I was in the lab for a year, and then the first big step in my career happened. I remember once, 6 months after I had completed the 4-year program, I was still in the lab. My best friend, who should remain nameless, was transferred out of the lab to become a test engineer, and I was heartbroken because I thought I was a better man than he was, and I was mad because they took him out of the lab before me. Of course, when you're in the lab, you look forward to getting out of the lab because the next step is to be a test engineer, where you own the testing responsibility for something. So they pulled him out of the lab to be test engineer on transmissions. It just broke my heart. And I made my feelings known to my boss, who told me that there was a better job coming up and that they wanted me for that. So that's why my buddy got this other job. Anyway, that eventually happened, I guess about 6 months later, when I was pulled out of the lab to become test engineer on engines.
You got where you wanted to be.
Boy, that was heaven, because that job had full testing responsibility for the whole rocket engine, and that was a neat job.
So this would have been about 19.
It's been 56.
56.
Yeah.
Okay. All right. So who would have been your boss at that juncture? Would that have been Burrow?
No, it would have been Belts, who was experimental engineer, but I didn't work directly for him. And I can't remember. It might have been Jack Wallace, but I'm not sure. Somehow I don't associate Wallace with engines, but I do associate him with the supervisor in experimental.
All right.
But I'm not sure. But that was a good job because I got to work with some people in the development group that really knew engines, Burl and Bob Tooker, Gib Butler, Tom Leonard, who taught me a lot, Frank Ball, Ralph Bird was in there. In fact, Ralph was the supervisor in the lab when I was in the lab. And that was a good experience. And I had that job up through, a couple, 3 years, I guess.
Mm-hmm.
And then I went on to do engine cooling work.
See, during that period, Jim, excuse the interruption, we were working on, is that the 3-carb era and all that stuff?
Yeah, the tricarb and what do we call that? The
J2.
J2, yeah. And it's interesting the way we worked in those days. Entirely different than the way it's done now, or even was done, I'm going to say, 8 to 10 years ago.
Mm-hmm.
Back in those days, of course, the product didn't change as much as it does now.
Yeah.
And we used to test and develop a change in the engine and have it fully tested, fully developed before it was ever released to production. Today, and I'll say starting maybe 8 or 10 years ago, it kind of evolved. A decision was made to produce a certain product based on a preliminary design, and concurrently a decision was made to put it into production and test it and develop it.
Ooh, you're running that parallel path?
Yeah, so you better hope you have it developed and tested by the time production starts.
And you better hope it's right.
Yeah.
Yeah.
And, to me, that's one of the most dramatic changes that took place in our business.
Mm-hmm.
And it was a slow evolution. When I was an engine test engineer, my boss would ask me about some characteristic of the production engine. I didn't really know. That was a whole bunch of historical stuff that came together. That was behind me.
Yeah.
Well, I was working on improvements for down the road, year X, and it's just changed so much in the course of my career, and it took its toll on reliability.
Do you judge that we did that for what reason? Speed it up or something? Speed up the process, or what was?
No, I think maybe the whole business. I'm just guessing, Jim. Your question's a good one. The whole business became more competitive, not only between GM divisions, but outside of GM with Ford and Chrysler, and then, of course, later the foreign manufacturers. So that there was an ongoing desire to do things that would enhance sellability quicker.
Mm-hmm.
You didn't have time to conceive an idea, test it and develop it, and then tool it and put it into production, end to end.
Yeah. So we had to do this parallel path thing.
Yeah, and or the car programs. Of course, I'm talking mostly engines. The car programs were another good example that a new car would require some change in the engine, and to make it fit or to make the engine bigger or smaller or whatever. And when the decision was made to do the car, the decision had to be made to do the engine.
Mm-hmm.
Whereas back in the old days, those changes didn't happen quite as rapidly.
Yeah.
So we had the luxury of making sure it was right before a decision was made to go into production. And I liked it that way because you really felt good about your product coming off the end of the line. Because you knew it was right, at least from an engineering standpoint.
And you had time to work your bugs out of it.
Yeah.
If there were any, assuming that.
And there was a certain feeling of pride when you'd see a new car rolling off the line that you had a part of assuring it was going to be right. Whereas later on, you were never sure what it was going to be like because production started and the test program wasn't done yet.
Mm-hmm.
And that's a fact. And that wasn't just engines, that was cars. The best example of that was a diesel.
Okay.
I don't have to tell you what a disaster that was. But there was such a compelling desire to get that into the marketplace.
But that was because of the oil crunch. Wasn't that the thing that was
Well,
pushing that to us?
sure, that's what was pushing it, but the desire to sell it and make a profit were really pushing it,
Yeah.
because we knew that people would want to buy it because they didn't have to wait in that long gas line.
Right.
Diesel fuel was a dime cheaper, and it was a powerful motivation to get into the marketplace. And the motivation exceeded our good judgment in engineering, because it wasn't ready to go when it went. And sadly enough, by the time what was the last year we made the diesel? 82, 3.
2, somewhere in there. Yeah, must have been 82.
It was
83 maybe at the latest. Yeah.
a very, very good engine then.
Too late.
4 years later, but nobody wanted to buy it.
Yeah.
In fact, when we conceived that diesel and had a plan to develop and put it into production, I think it was like a 2-year, maybe 3-year program from conception to production. And we had people from GM Diesel, the division, who was that?
The Detroit Diesel.
Detroit Diesel visit with us, and we shared our plans with them just to get their reaction. And they said, well, you never get this job done in a couple, 3 years. It's going to take you 5 or 6 years to get that engine developed. And we thought that's crazy, because it didn't take 5 or 6 years to develop a gas engine. They were right. They were right. Quite right.
Is that just because we didn't have the people to work on it, Jim? Just didn't have enough horsepower at the time?
No, it just, it takes time to grind out test miles and understand, if you fail a head gasket, it takes, 100 or 200 hours of testing before it fails, and then you have to analyze it, then you have to figure out what to do.
And then test that side.
And then you have to wait a couple of weeks or months while your vendor retools experimental tooling to make a new sample, and another couple, 200-300 hours of testing, and time just goes on.
It adds up fast.
And maybe that change didn't work, so you start all over again. And that's what takes so much time. Just the understanding of what was going on just took the time.
Did we do all that engineering kind of ourselves, or did we suck guys in from like Detroit Diesel to help us with those kinds of things?
No, we did it on our own.
So it was
of course, I say we on our own, we and our suppliers.
Yeah.
If you have a head gasket problem, for instance, your head gasket supplier would provide some technical assistance to solving that problem.
So we were plowing a lot of new ground.
All new ground. Oh yeah, oh yeah. And I remember on that project, I got to stop and think for a minute. Why don't you shut that off while I'm thinking? We learned a real lesson there. To me, the bottom line on why the diesel was such a disaster was this: that in a gasoline engine, the stresses on the parts are a function of the speed of the engine and the throttle only. More speed, more throttle, more stress on the parts. Not so with a diesel, because the throttle's open all the time. Wide open.
Wide open.
And the stresses at idle are maybe 80-90% of the stresses at full speed. We didn't know that, didn't realize that. So we were running tests in a traditional way, and evaluating the results. For instance, if we'd run 100 hours and 200, 300, 400 hours in the laboratory and something broke, we'd say, well, that's probably good enough, because people in the real world don't run that kind of speed.
Because you were running it on some kind of a hard test.
Yeah, not realizing it in the real world, that was, 80% of those loads were there anyway. So we didn't step up to a lot of the things that happened, thinking, well, in service it won't happen, because we overstressed it. We really didn't. That was true in a gas engine.
Mm-hmm.
You know, something happened 400 or 500 hours in the lab, a high speed, high load. You could assess that and decide you didn't need to react to it, because it wouldn't happen in the real world. It did with a diesel.
The diesel duty cycle was just more like a tractor engine.
Well, yeah, just because it was running wide open all the time. And that, in my opinion, is why we did an improper job in the diesel. We didn't realize that it was going to see those high loads in the field, even though it's just putting around town in some person's car. And that was the problem. But we're getting ahead of chronology.
Oh, yeah, that's okay.
Talking diesel, but the diesel might have been, I guess it was, my first experience in having to get something into production, at least in somebody's opinion, having to, and tooling it and testing it and developing all at once.
Mm-hmm. This parallel path thing?
Yeah. Rather than in series.
Mm-hmm.
And we paid the price for it. I think it really blemished our division. People don't forget.
No, they sure don't.
We had a reputation for the best engine in the business prior to that. And a lot of people bought our cars because of that. And then, you know, in those days, engines usually wore out before the rest of the car did. And if you had the best engine, you had the best product.
Right.
Not necessarily true today. So diesel hurt us. I think it really hurt us bad.
Why did we become the diesel makers?
Okay, good question. Because of Kelly Thurston. That's why.
Oh.
Remember Kelly?
A guy.
Kelly, oh, absolutely. Kelly came from Ethel Labs in Detroit. And Kelly was, he did a lot of things before he finally became our future engine development guy. He had a gang of people, and he went to Bob Dorscher and said, Bob, I think we ought to do a diesel, put a diesel into production.
Bob was chief engineer at that time?
Yeah. And, you know, Kelly told him why. Kelly was a good engineer. He was not a good organizer and presenter of, he wasn't a salesman, I guess I should say. So Dorscher shot him down immediately. He thought that was an insane idea. Who'd want a diesel in a passenger car, you know? Well, Kelly sneaked around and did some designs, got some parts, and started to do some work on the QT. And he went back to Dorscher later with some data, and he sold Dorscher on the idea, and that we should pursue it.
This would have been after the crunch started. Is that?
Yeah, this would have been, I'm going to say 73, 74, maybe 5. When did the first big oil crisis?
I think
74.
73, maybe, somewhere in there. Yeah, was when we got that big crunch.
So Kelly had, some units in cars, and they weren't too bad. Didn't smoke too much, and of course the need was there for such a product. It really was. So Kelly was a guy that made it happen. It was his idea, and he pushed it along, and he sold the program. Nobody else.
And other divisions didn't have any interest in pursuing the diesel?
Well, I don't know if they had any interest or not. They didn't. Of course, Chevrolet did later for the truck.
For the truck,
But I suppose that if one division got an approval, obviously, say Dorscher approved it, it had to go up the line to higher levels. And I guess if I was running General Motors, it's something that revolutionary, I wouldn't I wouldn't let more than one division take a shot at it. Thank God they didn't.
That's true, in retrospect.
So it happened, and then of course I got in a little bit of trouble too with the V6 diesel. The decision was going forward to do a V6. I was opposed to that because in those days the a diesel has some level of fuel economy right out of the box, and you can't change it much.
I mean, the design just kind of creates that.
Yeah, you can do a few things with ejection timing, but not much, and you just get what you get with a given design. Whereas with a gas engine, there was a lot of technology coming forward to improve the fuel economy, and it was rapidly catching up to the diesel. At the same time, the 10-cent advantage, 10-cent a gallon advantage diesel fuel had was diminishing. So as you look forward, even our first diesel, you had to own it about 50 to 70,000 miles to break even on fuel savings versus the initial cost. And that gap was closing between 78 and 82 because of the fuel crunch and the federal fuel economy laws and all that stuff. Gas engine installations were more efficient, and the diesel was level, so the gas was catching up. Fuel prices, the differential was being reduced, and the cost to produce a diesel engine was, of course, much higher. So if you look ahead and extrapolate all that out to the future, it said, we don't have any business to try to do a V6 diesel because it was an underpowered thing, and nobody would want to buy it for that reason. Plus, the economic advantage was it wasn't there, and the fuel crunch was going away. And that was one of those I told you so's, I guess. It just didn't work out. What did we spend for that plant?
$500 or $600 million.
Yeah, it was a bunch. It sat for years and years, and I got in big trouble with my management for poo-pooing that whole project. At the time, I was the motor engineer. I guess it was called powertrain engineer at the time.
You were the kind of the lone wolf out there?
Well, I was the Gilbert Burl of the old days. I had all the engine design development responsibility, and that was a big job I shot for that I made finally. And I was poo-pooing this brand new product that somebody thought was a good idea.
So who was pushing that? Was that just your chief engineer who was thinking that was great?
Well, of course, Bob Cook was general manager then, and he really liked the diesel. And Dorschmer was behind it. Everybody was, because we were really selling them.
Oh, yeah.
And that was long before its poor reliability was known to us. You know, that was maybe like 80 and 81, and that poor reliability didn't hit us till maybe 82 or 83 when those units got more miles that were out in the field. But anyway, the V6 never really got off the ground, took off. So. And I think it's true today. The reason more people aren't doing diesels is gas engines are so much more efficient. And not only, fuel efficient, diesel fuel now is usually a little higher than gasoline, I guess. And they're smoky and stinky, and they're not a very good deal. I really think the diesel was more popular with the people that worked at Oldsmobile because they had free gas and they could make it up north to their cottage and back. Bob Cook used to love that diesel. Boy, he was like all of us. He hated to buy his own gas. And he could get up to his cottage at Burr Lake, and he loved that diesel. And he didn't mind putting up with the noise. But I often wonder, myself included, I loved it for that reason. What our real liking would be if we were John Customer. We had to spend $700 more to get it and put up with the stink and the noise. And
underpowered.
Yeah, I remember one lady, we had to go out to her house because she lived in town. Her garage walls were all black. And you know how you get these, I don't know if they're cobwebs or dust webs that hang around in an old building. Her garage was all full of this black web stuff hanging. And it turned out what she did, her garage door faced west, and she'd start her diesel and then let it run for 5 or 10 minutes. Say it warmed up slow. Diesels did. And if you let them idle, it sometimes never warmed up. And she'd start her diesel and go back in the house and do whatever she had to do and let it idle in the garage for 10 or 15 minutes with the doors open and the wind blowing all the exhaust into her garage. And it was almost funny. You know, those kind of things happen with diesels that didn't happen with gasoline engines. They tend to turn people off. Well, anyway, you know,
back to the start again.
I guess in the history of Oldsmobile, one thing, if I can just try to recap,
Okay.
the significant to me that in those days, the late 50s and early 60s, repeating myself, we developed an idea and tested it and proved it a good idea before we decided to release it. That isn't true anymore.
Yeah.
It is true in some things, but usually you're doing it in parallel today. And that's not intended as a criticism. It's a fact of life to be competitive in the market, I guess. And so you get better at how you do your job than we had to be. We had all the time in the world to do what we wanted to do. Now time crunch isn't there, so testing today is more sophisticated and to get the job done more quickly and better with a time constraint. So where should we go back to, Jim?
Well, go back a minute to the what I'll call the original quote rocket engine. That engine must have been kind of a boilerplate engine, so to speak, because it lasted so many years.
Well, yeah, it was. It wasn't any tougher. In fact, it wasn't really as tough as, let's
Okay.
I shouldn't say all things. Most things are done out of need. What somebody said, necessity is the mother of invention. And you do what you have to do. You know, people run around today wringing their hands about ecology and waste management and so on, and I don't worry about that because we finally recognize the need to do something about it. And once the need is recognized, it'll happen. It'll happen. 20 years ago, nobody recognized the need. Nothing was done.
Right.
You know, there's no use wringing your hands of gloom and doom. We got it made now because we recognize the need. So that's why the old engines were heavier. They were tough. They were heavy. If something broke, you just made it thicker, so it didn't break anymore. You know? Today, you try to make it lighter and stronger at the same time, and given that need, you can usually succeed. Materials.
Were the testing and all of those things that were done on those kind of early engines, what I'll call technical kinds of tests that we did, were obviously different than what we do today. Were we able to get the data and the things we needed to better design things in the early days?
No, I don't think the test techniques are a great deal different now than they were then. They may be broadened, recognizing some customer experiences that we didn't recognize then. But they're essentially the same, I think. And I've been gone for
but I mean,
number of years,
your
but
time continuum that you were there.
You know, the engine goes around and gets loads, and it gets hot, and it has to have oil and water and stay at certain temperatures, and those things are fundamental. So your fundamental testing doesn't change. The life goals are different. The Quad 4 is a 1,000 hours cycling from full speed to full torque, up and down, 1,000 hours. Boy, a rocket engine of the late 50s would never do that. It'd come apart. Never make it. Never make it.
But you must have had some kinds of those tests that you did on the rocket engine to get you through something.
Yeah, we did.
To verify that what you have got is okay.
Yeah, and it was okay, you know, in those days. Cars didn't last as long. You know, you didn't need a 150,000 mile engine then like you do today. Galvanized bodies and stuff. And cars are going to last a lot longer.
Mm-hmm.
But there's, I guess the changes, at least that I observed in my career, are maybe more subtle than overwhelming.
Mm-hmm.
An engine's still an engine. And you don't drive your car any different today than you did 40 years ago, do you?
No, probably not.
Really? Not any different. I'm getting off the subject. Did I answer your question?
Yeah.
Excuse me, but I've had this cold and I can't get over this dumb cough.
Oh, tell me a little bit about, see, you said Gilbert Burrow was there and those kinds of people were all there as you initially started work in that organization. Tell us a little bit about Gilbert Burrow, because he apparently was the father of the rocket engine, so to speak.
Yeah, he was. He was, boy, if I have one, there's one person in my life that stands out as a really great person, is Gilbert Burrow. He was a brilliant engine designer. And he had, boy, it's interesting how things change. You know, he had the time to work on engines and to sit down with the guys at the board and go down to the lab and watch tests and go over to the assembly area and look at parts at completed tests. When I was a motor engineer for a couple of years, I guess. How long was I powertrain? A couple of years. Mm-hmm. And then the group got so big we split it up some more and I just became powertrain systems engineer. But anyway, I didn't have time for that stuff. I was busy with the budgets and all kinds of administrative crap and personnel and
no engineering.
Very little engineering, and not as much as I wanted to do.
Mm-hmm.
Burrow was all engineering. And as a result, he was really a principal in the rocket engine.
Mm-hmm.
You know, obviously a lot of other people made contributions,
oh, sure.
but you didn't do anything to that engine to change it unless you talked to Burrow about it.
Mm-hmm.
And he'd get you in his office and he'd ramble on for hours about his ideas, you know, and get you thinking. He liked to think by talking to other people.
Mm-hmm.
And you could just sit there and listen to him for 2 or 3 hours and not say a word, and he'd thank you for all your help. And all you were was an ear and something to stimulate his thought.
Yeah.
That's what he did. But he was really the guy that made the rocket engine. You know, he used to say, and I think this was true, anybody that can design and build an engine, but the guy that builds the best one, a good one, is the guy that pays attention to detail, and he did that.
Okay.
And another thing that's really interesting, you know, how you lose your way in that regard. Burrow never decided to put anything into production unless he sat down first with the people that were going to make the part. And he did that as he went along. If he had an idea for a new cylinder head, first thing he would do was get some drawings put together, and before he ever spent any money to build experimental pieces, he would get Pete Mitchell. Remember Pete Mitchell,
sure.
Director of the production engineering? He'd get Pete over. He says, "Let's smoked all the time and cigarette. Get Pete over here. Let's have him look at these drawings for it. Go ahead." You know?
Mm-hmm.
And that's what we did. Pete would come over and they'd sit there and look at all the drawings, and Pete would figure out how Burrow's objectives could be met, and Pete could make it. Likewise, he'd get the foundry guys in.
Mm-hmm.
And somehow we lost our way in that process, and we got back to it about the time I retired. We called it simultaneous engineering. You know, big deal.
Mm-hmm.
Hell, all we did was go back to where we lost our way, which is the right way to do business.
Mm-hmm.
Burrow practiced that all the time.
Interesting.
And I can't say whether or not other people in the building did, because I was really zeroed in on the engine group, but he did, and it worked because we had a terrifically good engine, as you know. There were There were other things he did that were different than the whole operation was different then. You know, in the late 50s and early 60s, when I was just a young buck in the engine business, and I evolved into an engine development engineer. See, in 61, I left experimental and became an engine development engineer.
Okay.
In that era, the organization was, of course, smaller. We didn't move into 66 till, I think, 1961 we moved in there. Remember the old engineering garage?
Mm-hmm.
And there was an office there.
Yep, right in the middle.
And it was one of those stand-up desks, the old green stand-up desk.
Mm-hmm. Foreman's desk. Yeah.
Outside of the office. And that's where the work orders were. If you wanted to have something done to a car, you wrote your work order there. But that was also the leaning desk, the standing conference desk. Or if somebody wanted to talk to you, you'd lean on that desk and talk to that person. And it was sort of the center of activity for the whole place.
Mm-hmm.
Lowell Kenning, who was an assistant chief, who was probably, he really kind of ran the place on a daily basis. The chief engineer, Harold Betzel, he did other things. But every morning, you know, when Kenning would park in the garage, the assistant chiefs and the chief parked in the garage, everybody else parked outdoors. And he would park his car and he'd walk over to that desk and he'd stand there and look around. And if he wanted to talk to you, he'd be around. He'd holler at you and have you paged.
Mm-hmm.
And he'd ask you about some hot project you're on or some hot problem you're working on. Today, you know, when I retired, you'd have a meeting in a conference room with 35 people and a bunch of slides. And in those days, you just met Kenning or Belts or somebody at the foreman's desk in the garage.
Mm-hmm.
And had your meeting there, a couple,
Mm-hmm.
3 guys, and you'd tell him what you're doing, and he'd okay, yay or nay it, and you'd decide what your next step is, et cetera, et cetera. And that's the way we operated in those days, as opposed to the big meetings of today.
Yeah.
Got the job done, it's very efficient.
Mm-hmm.
I get that, to me, and I think back in history of Oldsmobile, at least in the engineering department, that to me is a good measure of how we've increased in size. And how many cars did we build in those days compared to how many today? Do you know?
We had 3 cars.
Yeah.
88s, Super 88s, and 98s, but they all use the same engine.
How many did we sell? Did we sell 500,000?
We sell 580,000 in 1955.
Okay, so today,
Today we just sold 600,000.
We just sold 600,000.
Yes, we do. We're regressing.
And what we got up to 1 million. So
yeah, but the million was in the 70s, so
yeah.
But still, it was.
So we built twice as many cars with probably 5, 6 times the staff.
Mm-hmm.
I don't know. It was a disproportion because we got everybody wants everything, and complexity is model complexity is much
But
greater.
now we had several engines by then. We didn't have the single old engine that we had in the 50s.
Right, right. The whole place changed, you know, and then I'm supposed 20 years before that it was even simpler. They probably had one guy doing all the engines.
Okay.
But, you know, when you asked me to come over, I got thinking about, well, how have things really changed? And I miss those days because it was, you know, an engineer is an engineer because he wanted to be an engineer, and he had a chance to engineer.
Right.
When time went forward, the engineer has less and less time to engineer. And as more and more of his time is taken up in other things, administrative tasks and paper and meetings and making flimsies, and so he can impress somebody else with how great his idea is because the flimsies look nice and all that sort of thing. That doesn't, maybe it comes out negative. I don't mean it to sound negative, but it's just an evolution that occurred. And I remember I used to work for a guy that said, boy, things are sure a lot better than they used to be. He was talking about business things, and I said, well, you mean they're better than when everybody loved working here and stock was $100 a share and we were making a profit whether we tried to or not, better than those days. So I'm not sure what he meant by better. But I never thought it got better because it's too big.
Was that part of the problem? We got too big?
Well, I think so. You know, the reorganization was because we got so big we couldn't get anything done. We got all bogged down, and well, that's another story. But yeah, and you think back, in those days, life was simple, and you could concentrate on doing what you were there to do. That is, design and develop and test a product. That's what you did. Today, it isn't what you do. That's kind of something you do in addition to other stuff that of necessity, I suppose, that simply supports that. And the poor general manager today, the general manager then could decide, you've heard this before, he could decide what he's going to build, he's going to build it or buy it, and he could make all the decisions that make it happen. Today, the general manager gets an idea, he's got to look around for somebody to make it for him. And if he is fortunate enough to find somebody to make it for him, then he has to have them make it the way he wants it instead of the way they want to make it. You know, some of that, that's just a price we're paying for size, I suppose, Jim. But size changed a lot of things. Government intervention, obviously.
Yeah,
you know,
that was a big thing that happened to us.
And we should talk about that
Yeah,
a little bit after we take a brief break to handle this coffee.
Okay.
Just to kind of get the chronology in order, I was, aside from the diesel engine, talking about how we operated and what we did, and some of the people from a period of about 56 to about, I'll say 61. And in between 61 and 66, I was when did I was a 7th level senior project engineer, engines. And then I got promoted to motor development engineer, which is a supervisory job in 1966. So I guess, that's right. So I was a supervisor then, the first level supervisor of the engine development guys. And those are good times. That was really the fun job because you get to engineer without all the grubby detail work that goes with it, and you're working with a whole engine instead of just your own components. And then we picked up fuel systems then too in the late 60s.
You're back to the gas tank?
Yeah, because that's when all the emission stuff was starting, the exhaust emissions and the evap emissions. So the engine group had responsibility for exhaust emissions and responsibility for the evap emissions. So it made sense, and the design of the gas tank and the entire fuel system was part of that, so it made sense to take the gas tank, which was in the chassis group, and put it into the engine group. That's probably about 66, 68 when that happened.
Okay.
And that's when Bob Stempel was assistant motor engineer, and then he became motor engineer after that, and it worked. Or was he assistant then? I guess he was assistant then. I'm trying to remember. But that's when I worked closely with him. Terrific guy.
Was he?
Yeah, he really was.
Was it obvious that he was going to be something? Or not?
Well, yeah. I was quoted in the paper not too long ago as saying, he had it all. And he did. He worked hard. He was smart. He was good with people. He'd come to work at 7:30 in the morning and leave at 6:30 at night, and he'd work all night at home. He'd come in with a stack of papers that had reports his wife typed that night.
Oh my goodness.
And he was night and day all weekends, and He never talked about socializing with people. Like we all said, well, went to movies or dinner with these people, that people, went to football game, et cetera, et cetera. He never talked about that stuff. He didn't do any of that stuff. He just worked and worked and worked.
Interesting.
So you just knew this guy was going to make it. And then he went back to school. 2 nights a week he'd drive to Detroit to I guess it was a Wayne State extension someplace. And he'd spend from 6 till 10 o'clock at night in school working on his master's.
Oh,
Gee, Bob, that's really, why are you doing that? He'd say, well, it's pretty obvious if I'm going to be competitive with other people in General Motors, I got to get more education. Get some business in addition to engineering. So he, in my opinion, deserves what he got. You know, he made it. He made it. But I make a joke about it. I says, well, it's Bob's my age. In fact, our birthdays are within a month. And I'm 57. So when Bob retires at 65, you'll have to say, well, the guy was kind of a failure. Had the same job for 8 years. But anyway, then so I did the gas tank thing, and up until about 2 years ago, was heavily involved in a lot of post-collision fire lawsuits against General Motors. That wasn't any fun. Boy, there's some horrible things and big suits against us. All of which the ones that go to court, we win. But anyway, I was 8th level supervisor, and I also had fuel systems, which was a tremendously fun thing to do because you couldn't go to a book or archives and learn anything about how to design a fuel system to control evap emissions. Nobody had ever done that before. So we really plowed new ground in that whole subject, and that was a lot of fun. It was a very interesting, challenging work.
Now, were we doing it just for Oldsmobile, or we were doing it for kind of everybody?
We had fuel system coordination responsibility for GM. It was about the late 60s that coordinated design things started, and we had fuel system responsibility for all the coordinated cars. And I was chairman of the coordination committee for a number of years. So through the efforts of the coordination of Oldsmobile and the efforts of all the divisions, we got the job done. And then divisions that had specific cars like Corvettes and Vegas, they would come to us and seek our counsel too. So we really kind of did it for GM in a sense. And then in 72, I made unclassified, and I became assistant experimental engineer, powertrain.
Okay.
And that's when the emission thing really got heavy, because the standards were getting tighter and tighter and tighter. At the onset, we could meet the standards, and EPA looking, projecting future standards, is pretty obvious we didn't have the foggiest idea how to meet those standards. So the struggle began, and then in 74, 2 years later, I became emission engineer, reporting to the motor engineer.
Now, was that a split? Is that when, did the department split at that juncture? Or?
No.
Okay.
This is when the engine group at this time now was just like it was when I worked there.
Okay.
Except it had the fuel system.
Yeah.
In about 1972, when I became assistant experimental engineer, there was a job created, maybe it was slightly before that, in the engine group. There was an assistant to the department head on a level with, Tom Leonard had all the development then, which was the emission end of the business.
Okay.
Prior to that, at the onset of the emission regulations, each of the engineers had a little piece, and kind of collectively got the job done. But the job was getting so big that it became necessary to create a specific group of people within the department who worked on emissions. emission development.
Mm-hmm.
And
they did the whole engine.
They did the whole emission.
The whole thing, gas tank and the whole works,
everything.
they did all that.
Yeah.
Okay.
And I got that job. I wasn't the first to have it. Harry Lyon had it before me.
Okay.
I'm not sure if anybody had it before him or not. I'm not sure. But I took it over for Harry in '74.
Now, were you all by yourself, or did you have some folks with you?
Oh, I had a whole gang of people working for me.
All right.
We had one group of people that worked on the system, defining the system. They would calibrate the carburetor, they would determine the spark curve, they would determine what had to be done to reduce emissions. And then another group of people had the responsibility for developing the components. Prior to that, the carburetor guy would be working on emissions, and the distributor guy would be working on emissions,
Mm-hmm.
and the carburetor guy would say, well, I've gone as far as I can go with carburation. The additional reductions in tailpipe emissions are going to have to come from somebody else. And somebody else said, well, I've gone as far as I can go. So
you always stood one of these.
we reorganized the thing where certain people had responsibility to get emissions down, and other people had responsibility to develop the components that they said they needed. And that was probably the most frustrating period of my career. We used to have a joke. There was a committee headed by Newell McEwen at the corporation called the Emissions Subcommittee. And I was, of course, on that committee as emission engineers, and every time somebody became emission engineer, we said, where'd you screw up in your career that they're punishing you like this?
It was that bad.
It was horrible, because you had the challenge of trying to do what the feds demanded you do, concurrently that you didn't know how to do. Concurrently, you had to develop scenarios, databases to go back to the feds and say, hey, you guys you're pushing us too hard, too fast, we can't make it. Concurrently, there was a fuel economy standard, which was, completely counterproductive to what you had to do, and what you had to do to reduce emissions hurt fuel economy. And I'm not certain why. I'm still not sure why it is today. Seems like if your tailpipe emissions are down, the engine's more efficient. You ought to.
Yeah.
I don't pretend to understand that. I suppose somebody does, but I never did. But anyhow, all that was happening, and it was so frustrating because nobody in the whole world was going to buy an automobile because it had low emissions. Nobody.
Didn't sell cars.
Maybe one or two do-gooders. So you're working on an area, spending probably more money, resources than just the basic engine development. Huge lab. You've seen our emission lab. Huge emission lab. All kinds of technicians running around running emission tests and maintaining the equipment and computers and big bucks. None of it selling an automobile. Now, it had to be done. The world needed to have it done. But in those days, we didn't appreciate it like we do today. We didn't appreciate that the need existed. And the feds have your feet to the fire all the time. And if you run an emission test to qualify a car for production, which was at the 11th hour, your hydrocarbon limit might be 0.419, I forget the exact numbers, and you'd run a test and you'd get 0.420.
You flunked.
You flunked, and either flunked or you passed. There wasn't any almost.
No gray area.
And I, as an engineer, I couldn't identify with that. I knew that product would meet the standard, but that particular car tested on that particular day didn't happen to do it because of a test error and the variations in the weather and all those things. It create that. You missed it by thousandths of a gram, and that's just so frustrating. And that was a frustrating period for everybody involved in emissions. And now those poor guys are going through it all over again with fuel economy standards. I was talking to Joe Jones about 2 months ago. He is now the emission engineer, and he says, I think about you, Jim. He says, I'm going through the same agony you went through in 1975 and 1980.
Everything recycles.
You know. And that wasn't just the federal government. California had another set of standards, even more stringent, so you had to wage a battle twice. And it was very, very frustrating. And it was a great day in my life when I got out of the emission business. I mean, it was really a celebration.
How did management view all that, though, Jim? You mentioned like we spent a lot of money, a lot of effort, a lot of man hours. How did they feel about that thing in those days?
Well, nobody liked it.
But it wasn't the case they weren't supportive, was it?
Of what?
Supportive of doing the task.
Oh, didn't have any choice.
Yeah.
It was law.
Yeah, so
you
we
know.
did it.
In the trials that I participated in on fuel systems, we very often got into words like the lawyers do, good words that, and this is applicable here. To meet, let's say, if you had a goal to make an engine run 100 hours at wide open throttle before you go into production, that's a goal. If it only ran 99, you'd usually go to production.
Sure.
But with emissions, it wasn't a goal. It was a requirement. You could not make any engineering judgments on whether or not your production vehicle would in fact attain the requirement. You had to demonstrate it to the thousandths of a gram. So am I making that clear?
Yeah, sure.
So we, for the first time, were dealing with requirements, and as engineers could not exert any judgments about our product.
It was day and night.
Just had to go by the rules, and some of the rules were dumb. And I guess I thought a lot of them were dumb because they didn't have any. They didn't allow us to make judgments. You know, if you could have a dozen in-house tests that would demonstrate that a design would comply. But one car that EPA tested in their lab in Ann Arbor happened to be 1,000ths over the high limit, where you might have a whole bunch below that in your stable. That whole bunch didn't mean a thing. So, and that's what was so frustrating, having to go by those rules. Of course, the rules changed a lot in the later years because the feds, and I'm not criticizing them, they had their job to do too, but the administrator was struggling with what is the right thing to do to get this job done. And they didn't trust us, and we didn't trust them, and it was not a friendly relationship, a very adversarial relationship. And I guess maybe they were justified in not trusting us, I don't know. We didn't cheat. We wanted to use judgment, and I guess they called that cheating.
With R. James Benner of 405 Harper's Way, Lansing, Michigan, 48917. The recording was made by Jim Walkinshaw at the Oldsmobile History Center on October 11th, 1990. This is tape number 2 of 2 tapes. Okay.
But, you know, in spite of the frustration, it does prove one thing, that technology is advanced, the world does get better. If somebody pushes you harder than you'd rather be pushed, you know, we meet the need.
Mm-hmm.
And it's true in the automobile business, and I really believe it's true in all walks of life, that progress is made because we get pushed. Mm-hmm. We don't like getting pushed. But you look back on all that, you say, well, we did some things that we wouldn't have otherwise done, and the world's better for it. But boy, when you're in the middle of it and you're the guy getting pushed, it's no fun. Mm-hmm. It's no fun. Mm-hmm. But we made it. You know, we got there were some years that certain cars weren't available in California. There were lots of years when we couldn't produce certain cars at the start of production. I remember Dennis Duffy he had a big job in materials. Yeah. And Dennis was the guy that I had to visit with, and there were others there in the room. Starting about a month before production started, I'd go down there every day, and I'd tell them what cars were certified, what they could build, mm-hmm. and what they couldn't build, and if they couldn't build certain cars, I'd tell them in my best guess when I thought they could build it. So they had to get all this material scheduled to build just certain kinds of cars with certain kind mm-hmm. of engines and mm-hmm. axles and transmissions. And how those people ever got that done, I will never know. I tell you, I developed such a respect for material people. You just say to Dennis, you can't build this car with this kind of an engine. To start a production, he'd say, okay, we'll build something else instead. He went into that system and got it done. Mm-hmm. I don't know how he did it, yeah. But it worked. And we made some big changes in the way we did business after I became a mission engineer. You know, engineers always want another day to do it better. Mm-hmm. You know what I mean? Yep. And as a result, these guys that were trying to develop the fuel economy and emission systems could never quite accept that on some day they had to stop.
Get done.
Mm-hmm. Because production was going to start 3 months later. They said, well, I think it's Thursday. I think by Monday I can have this. Mm-hmm. Well, Monday they run the test and think, well, almost worked, so we'll try something else. And about Wednesday, yeah, they made it. But a week slipped by, see. So I remember once we had a big meeting, a conference room. I called all my guys and I said, from now on, we're going to establish drop-dead dates, and you will have your job done by that date. And we're talking like a year ahead. Mm-hmm. Does anybody in this room know of any reason why we can't define our durability cars by this date, get them going, and can't define our data cars by this date and get them going? Anybody in the room think any reason why we can't do that? And I'm talking a year ahead.
Yeah, oh yeah, long time, yeah.
And the room is silent. Mm-hmm. And so I said, well, what we're saying is we're going to do it. We're going to get certified by start of production, so I don't have to visit with Dennis Duffy and go through his agonizing meetings and catch all kinds of hell. And one guy popped up. He said, well, what are we going to do if we find something that improves fuel economy a mile per gallon, using just an example, a day after the dates you established? So you're just going to have to wait another whole year to put it into production, that's all. Well, those guys did not think in terms of having to meet a date. They were pure engineers mm-hmm. out there doing their thing, and they were good engineers. I was so proud of those guys. They were good. Bob Rich, he made probably more contributions to the world of emissions and fuel economy and drivability than anybody at Oldsmobile ever that I know of.
Interesting.
Fantastic guy. But Bob's a pure engineer. He had no business sense. He had no startup production timing sense.
You just put him in a closet and
Yeah. And I never forget that meeting because finally, after quite a little time of dialogue, the guys realized what I was trying to say. There's a day when you're going to have to stop and give me a decision on what you're going to do. It worked, except for a few glitches. We had everything ready to go when the line started.
The guys came to the party.
They came to the party because the word was, if you can't be done by that date, at the minute you know you can't be done, you come to me and tell me why you can't be done, and we'll try to react to that. Nobody ever came to me. Never once in 2 years.
Well, that's a major philosophic change.
Yeah. So that helped a lot. That helped those agonizing 24-hour sessions on Sunday at 3 o'clock in the morning trying to get certified because the line wasn't going to start Tuesday or something. That was miserable. Then in according to this piece of paper in front of me, 1177, I was talking about from 74 to 77.
Yeah.
The years I just soon forget.
Yeah, right.
I became powertrain engineer.
Okay. Was that what it was called then?
Yeah.
Okay.
Because used to be the engine group. It was an engine. In the old days, it was engine group, and there was a transmission group, and that all came together. I don't remember when.
Prior to you arriving there?
Yeah, the engines and transmissions and all things that made the car go were put into one group.
Okay.
Not just the motor wasn't one group, and the transmission another group. So I got that job of powertrain engineer, which included the differentials, the transmissions, the engines, developing, designing thereof, the emission compliance, and all those things.
Okay.
And I was a department of some, boy, it's a big department, 90-some people.
Okay.
And
all engineers, basically.
well,
did you have the drawing side of the house at that time?
I did drawing side.
Okay.
Yeah, they're all technical people. And management expected, I guess just out of history, for that office to know every little thing that was going on. And there was just too much to really know as much as you should know. So, and then I had a alleged heart attack about 79, and I think that might have made people realize that either I was incompetent or the job was too much or something, because you couldn't do it. You're still an engineer now, and you like to know a lot about the detail of what's going on, and there's so many, your span of control was monstrous, and you just couldn't handle it. So the decision was made to reorganize and have the group split up into emission development, transmission and drivetrain development, and basic engine development. When I say development, I mean design and development. 3 groups, each of whom reported to an assistant chief, rather than one group, and it was more manageable. Well, I got the emission side of that business.
So they sort of went back a little bit to maybe the way it was a little bit previous, except emissions existed there.
Yeah, except it was sort of up-leveled. When I was emission engineer, then later became powertrain systems engineer, I kind of did the same thing. But in addition to having to develop the emissions, I also had control of the hardware, and I dictated, I don't mean me personally, but our group dictated what the transmission was going to be, what the axle ratio was going to be. The whole powertrain was dictated. I dictated to Tom Leonard what compression ratio I wanted in the engine, and other engine characteristics required to meet emission and fuel economy standards. And that was born out of need because everything we did then had to meet emission and economy standards. And there wasn't any compromising. You had to do it or you didn't go to production, period. So you had to dictate what compression ratio you wanted and what axle ratio you had to have and all that stuff. So, well, just to put it into perspective, our gang did that, and then we would dictate certain engine characteristics, and then Tom's gang would design and develop the engine to that characteristic, and Art Wiedemann was on the transmission side. He'd do the same there. And that was a little bit of an adjustment for everybody. But it worked. It worked. We got the job done. But things are really getting complicated then, because, well, when did we put the Chevy engine in the Oldsmobile?
77, I think. 77 or 78.
Yeah.
So it was during those years when we were making 1 million cars, or trying to make 1 million cars.
Yeah, and it was all started to kind of tumble in. The emissions and the fuel economy standards, the product complexity was happening then. I think the Japs were starting to make inroads into our business, and the fun of engineering, at least for me personally, just kind of went up in smoke. And now it was make the government happy, make some guy in the other end of Detroit happy because he wants to use your engine and make a change in it that you don't want, and all those non-engineering things. More emphasis on, I guess, quality of work life didn't happen until a little later.
That
But
may have been about 80 or so, that QWL, the early QWL stuff.
there was a more personnel activity at that time. I guess I don't know why. There was a fear of another societal change. Equal opportunity. Be careful what you say to who. Don't fire anybody unless you can document the hell out of it. You're going to end up in court.
Right. Hire your quotas.
Yeah, and all those kind of societal pressures too, and tended to dilute what you wanted to do as engineer an automobile. And the world was changing fast, which I think had a big impact on our business. I'm sure there were other forces that don't come to mind today that took the traditional old-fashioned Gilbert Burrell motor engineer that sat there and designed engines with his staff, as opposed to the motor engineer today that goes to Detroit 3 days a week for meetings and sits in personnel meetings and all that kind of meetings. And I'm going to just step aside, take a sideways step for a second, and QWL, often think about that. Have you noticed when you retire how things come into focus when you're gone? And you say to yourself, boy, did we ever do that wrong? If I had another shot at it, here's the way I'd do it today. That used to happen to me when I was on vacation. Did that happen to you? You go away on vacation, if you're fortunate enough to get a couple, 3 weeks.
A long one, yeah.
You just step back out of the woods and you look at the whole woods and you think, the whole forest, and you think, gee, we've been doing that wrong. QWL, interesting. Can I talk about QWL for a minute?
Oh, sure. It's part of the subject.
QWL meetings, we had a QWL committee, and to me that was, probably shouldn't put this on, that was appease the union. To me that's what QWL was, in retrospect.
It was,
appease
to some degree.
Appease the people. Start off with the union and then went into the salaried ranks. And we did all kinds of things. You know, we redecorated the ladies' room, and we put in water fountains and put in air conditioning and all those nice amenities, you know. And we created employee involvement and all those nice things. That is not, in my opinion, in retrospect, what QWL is. We did it wrong. They were still doing it wrong today, I don't know. Back when I started working there, you didn't need QWL because it just happened because you were all happy as a lark designing the world's best engine that everybody in the world knew was the best engine, and you were a part of that. And QWL happened.
And you didn't know what it was.
Didn't know what it was.
Right.
We were happy as the dickens. You know, I'd have died to make that engine better.
And you didn't need a purple drinking fountain.
Exactly. And have you ever noticed when you're working around the house on a project that you really love, you're just having so much fun you don't even stop to have lunch?
Mm-hmm.
Now that's quality work life.
Good.
Ask a guy today to not stop and have lunch. I want you to have fun in your work so you don't have to eat lunch. He'd laugh at you.
Yeah. Yeah, he'd think you were out to get him or something.
Yeah, so I think we missed the boat. QWL should have been, at least in product engineering, those things that help us do our job better so that we can take pride in having done that job. I mean, that's why we're there. We don't come to work to be amused,
Mm-hmm.
to be comfortable in air conditioning, to have purple water fountains and pretty wallpaper in the ladies' rooms and all those things. We come to work to build, design automobiles, not to experience those other things.
Mm-hmm.
And we lost QWL when we lost the individual rewards we received from a job well done, because we couldn't do the job we perceived we were going to do when we hired into the place, if I'm saying that right. You know. I couldn't design engines anymore because somebody wanted it to burn clean.
Mm-hmm.
I'm not saying that's wrong.
Yeah.
Than what I hired him to do. So we kind of lost a built-in QWL in the changes in their history. And again, I'm not trying to sound critical of those changes. They were very necessary for society and for energy conservation and for lots of reasons. And maybe 20 years from now we'll learn how to deal with them. And we haven't learned to deal with them yet, a la the major reorganization that's frustrating people. And I just had dinner with Tom Gerben last night. He used to work for me when I retired, and he heads up the engine testing, and they're still reorganizing the engine business, I guess.
Yeah, now they're all General Motors or something.
Yeah. So, and maybe when the smoke clears, the smoke settles, dust settles, the smoke clears, they'll find that built-in QWL again.
But the problem will never get back to where you can identify yourself with a specific thing anymore. I'm afraid that's what's never going to happen.
I think you're right.
When we build an engine for an Oldsmobile, then you could put your arms around the whole thing and say, this is my share of that.
Yeah.
It's hard to do that.
Yeah, that's right. Yeah, I could drive my company car home to back east to visit my family, and I could visit my brother and my old high school buddies, and I could raise a hood and say, you know, I designed this thing here, and I designed this thing, and this is my idea. And you'd open the hood of a car today, and there's probably a dozen people who run up and say they had a little piece of that one part, because of the way it just has to be.
So you take me back for a minute, Jim, if you would, to the 60s again, when we were working on like the new F-85 and the so-called 654 and 657 engines and those kinds of things. What precipitated those Do you have some views that you could share on those things? Why they came to pass? Like the new little aluminum engine for the
Yeah.
F-35.
Maybe that was the onset of the GM method of operation where all divisions wanted all kinds of cars. You know, in the old days,
Yeah.
Chevys were little and cheap, and Cadillacs were big and expensive, and the other three were in the middle.
Right.
And then it evolved into Cadillac wanted a big traditional Cadillac, plus they wanted a little bitty J car too, which
Right.
they had for a while. Nobody bought any. Maybe that's what happened then, Jim. I guess I don't really know that we started to spread out then, didn't we, in our
Yeah.
market, our niche in the market.
Got more kinds of cars and more complicated.
Yeah, yeah. And you know, we lost our divisional identity when that started. You know, that little aluminum 231 was a Buick engine. I guess we had our own heads.
Yeah, it had our own top of it. But
And you could go into, you know, today you can go into any GM dealership and buy the same darn thing you can buy at any other GM dealership with just another name on it.
mhm. It's true.
Was that the right thing? There are a lot of people that believe that GM has kind of lost market penetration for that reason.
Yeah.
You can buy an Oldsmobile in any one of
Mhm. Go to the Chevrolet dealer.
5 dealerships with a different name on
Yeah.
it. I don't know. There's no answer to that question.
Yeah.
But I guess maybe that was the start of all that, the little F-85.
Yeah.
Because prior to that, we were strictly big cars,
Yeah,
weren't we?
just the 88s and the 98.
Yeah. I hadn't thought about that, but that might have been the first step.
See, when we got rid of the, quote, the original rocket and went to the 654 and 657 engines, was there some driving force there that caused us to want to do that?
Well, there were two. One was a 455 and the other was a 350.
330, they started out and ended up 350, yeah.
I guess that was because not all our cars are big cars anymore, don't you think? And you don't put a monster engine in a little car. I mean, we did that, but
Yeah.
not in all cases.
Yeah.
I don't know. I guess just because you needed more product diversification.
Yeah.
I'm not answering your question, but I don't know
No,
how
that's
to.
okay.
I don't know what the
Yeah.
answer is. And,
I don't know that there is an answer.
and you know, maybe in your study there's a way to plot out on some kind of a chart the explosion of product diversification.
Well, you can see that. I've got a chart that shows everything we made, and the first one is one page, 8.5 by 11. The last one is a fold-out that's that long.
Yeah, that
Shows you.
Yeah. And did that explosion start in the?
It starts in the sort of in the 60s.
Yeah.
Yeah.
Yeah, I guess that's
Yeah.
about right, isn't it?
Yeah.
And out of that explosion came the old coordinated design concept.
Mhm.
And later, as that curve went up exponentially, the reorganization of General Motors.
Mhm.
And see, something happens because I drive past that Human Resources Center, Waverly and St. Joe,
Yeah.
and here's this whole building, which is what we used to call personnel department. When I hired in, there were 15,000 people working at Oldsmobile, Jim.
Something like that.
You and I were students,
Yeah. Right.
plus another bunch at Fisher Body.
Right.
Didn't have a warehouse then, did we?
Yeah, we did. It was in the building 62. But we didn't
Oh, I
have a new
meant the
warehouse.
one out
no,
on
no,
Mount
no.
Hope.
It was an old warehouse, yeah.
And the personnel department that handled all that occupied this wee little tiny space over in 62, I guess it was. Right? Now, how many people work at Lansing Automotive Division? 13,000, I read.
Oh, no, I think it's 22,000 maybe in total.
Is it that many?
Yeah. Something like that. That includes Fisher, though, now.
Yeah. So if you took the old Oldsmobile personnel department back in the 50s and combined it with the Fisher, they wouldn't even occupy a quarter of the first floor of that building, that four-story building. It's all full.
Sure.
So why is that? What in our history has...
The same thing happened to those guys. It must have happened to our engineers. More demands, more needs, more government help. Perhaps maybe has done the same sort of problem.
HRM,
Yeah.
equal opportunity.
All that stuff that you ended up having to deal with as a supervisor.
No industry's dealing with that.
Yeah.
Wasn't that overhead?
Oh, yeah.
I read in the paper where the average cost of an automobile is 60% of the average annual income. Never before in history has a car been such a big percentage of average annual income. Read that.
I read that.
And cars are getting too expensive.
So I know as a proportion, if you think back to what you made originally and what the car cost versus what a new higher-end engineer makes now versus the car cost, hasn't changed much.
But on a national basis,
That's a national average, apparently.
it has.
So that must be
It's high.
one of two things. Either the price has gone up and the national average has gone down, or
Yeah.
something. But from a standpoint of a specific individual, it hasn't changed much.
Well, an individual that works for Oldsmobile.
Yeah, I think in terms of a new hire in 1951 versus a new hire in 1990, and he could buy a car for so much in 51, and it took so many years or half years to make one, versus today, how many half years he'd have to work to get the same basic vehicle.
Yeah.
It's about the same average, same cost per, or same half year.
Same ratio.
Yeah, same ratio.
I think you're right. But that is different than the national average.
Yeah.
You know, the other thing that's, if you want to play with numbers for your book, I don't know if it's important to your book, but it's cheaper to run a car today than it was in the 50s.
Yeah.
The cost of fuel, the efficiency,
Yeah.
and we rave about $1.33 gasoline. That's still cheaper than it was when you and I were in high school.
We only paid 17 cents or 20 cents a gallon.
Yeah, we were thrilled if we got 14 or 15.
Yeah.
16 was hog heaven.
Oh, yeah.
So,
Changed oil every 1,000 miles.
yeah.
Had your
Yeah.
valves ground every 25,000 or something.
Right. It really is cheaper to run a car today.
Yeah.
And
Jim, tell me about some of your chief engineers, how they managed their business a little bit. Those that you can perhaps remember.
see, I was thinking about that. Since you called, I thought about a lot of these things. And I can't compare chief engineers, and I'll tell you why.
Okay.
Harold Metzel was the chief engineer when I was just a young buck in the lab.
But he must have impressed you as something.
Oh, yeah, he impressed me as sort of sitting on the right hand of God, you know.
Okay.
He's in his office all by himself. He always had his suit and his tie. He looked nice. He'd smile at you politely as you walked by. Didn't know who the heck you were, but he'd give you this nice, polite smile, and boy, you were just thrilled if he said good morning and called you by name later on. You were so excited.
Leaking in there?
No.
Okay.
Okay, then Bob Dorschmer, when I retired, was, let's see, who was chief engineer when I retired? Of course, when I retired, it was altogether different. Ron Haas.
Yeah, because Dorschmer had gone down to the
Yeah.
Corps.
Well, Ron and I, we were social friends. We came up through the organization together. Very close person. Actually, you can't say close personal friends. We were personal friends. Bob Dorschmer before him, we were personal friends. Drank beer together in Phoenix on test trips.
Yeah.
The point being that as my position in the organization went upward, I got closer to the people that were chief engineers, so how I view them is influenced by where I was
Sure.
looking
Your position.
from,
Yeah,
see.
yeah.
And I think we were blessed with really good chief engineers at Oldsmobile. I mean, in my opinion, we didn't have a bad one.
Good.
And that's an interesting, leads to another thing.
Okay, the work ethic?
Maybe that's not the right word. The way we did our business of engineering the car was distinctly unique from other divisions and better. Now, that's not from my point of view, because I didn't know a lot about how the other people operated in those days. But when you didn't agree with somebody else, naturally you thought you were right.
Mm-hmm.
There are times, but suppliers would tell us that we really ran our business well.
Because they were dealing with both, or all of them.
Yeah, and they could say, well, they just told you that because they wanted to butter you up. But I don't believe that. They didn't. And we got into coordination meetings and sat down and talked to other divisions and their people in more detail. Oldsmobile, more often than not, would win out in discussion about, what's going to be this way or that way. And there was kind of a philosophical way of doing your business that was just passed on through the organization from the Metzels and Kinnings when I started, and probably down from the Skinners and Wolframs before that, right up to the Ron Haases of when I retired. All had that kind of that way of thinking. And you identify with it. I grew up having been taught to think that way, or learning to think that way, because that's what my management thought, and that's the way I taught the people that worked for me, consciously or subconsciously. So all those guys that ran the organization were kind of the same, because they're out of the same mold, out of the same family. And they were all good. And they had a good philosophy about what an automobile ought to mean to people. And good, honest, straightforward, honest engineering, no fancy stuff.
Yeah.
I'm getting off the track of your
okay.
question,
No,
I
that's
think.
all right.
What was your question?
Well, the question was how these managers managed, so to
Yeah.
speak, or how
Well,
they
they're
ran their business.
all
or
kind of the same.
How,
Now, the one guy that was different was Howard Carroll. Howard came to GM. He was previously a physics professor, I believe, at Notre Dame.
Good bit.
And he was different. And he was, you realize this in retrospect, he was different because he didn't grow up with that gang. The Orsher grew up with the gang. Belts grew up with the gang. Stemple grew up with the gang. Haas, but not Carroll. Who were some of the other chiefs in here?
Belts.
Belts, yeah, he grew up with the gang.
I think those are those.
Yeah, I think so, Jim. They were all, in my opinion, good guys.
Well, did Carroll then, did the railroad run different, so to speak, when he was there?
Well, he wasn't chief engineer very long, as I recall.
Relatively short period of time.
Yeah, I bet it was less than a year, wasn't it? I'm just recalling off the top of my head.
Short time.
No, he was a good, honest guy. We didn't operate on bullshit, pardon my French.
Okay.
could sit in meetings with other managers, other divisions, who were lots of times bullshit artists. Now, I suppose the world is mixed with good, honest guys and bullshit artists. But I never saw any bullshit artists running the place at Oldsmobile Engineering, or anywhere in Oldsmobile for that matter. Even manufacturing, I didn't know those guys as well, obviously. Darn good, capable people, all the way through. But you get into other divisions, and it wasn't that way all the time. And I don't know what it's like today, but maybe that's an unfair statement, but I know of cases where other chief engineers and other managers were pulling hanky-panky stunts, and our guys were straight shooters. It always made me proud, you know. So, no, I think, I guess maybe I was sounding a little critical here this morning. And not of people or of the business or of General Motors, but rather of the evolution that has taken place in what we do because of what we have to do, because of competitive pressures, societal pressures, the growth of our business, and all those things we've discussed. I wonder if there's a period in history of Oldsmobile, and I say Oldsmobile, and I'm still talking about the Lansing manufacturing as part of that, in the use of that term. If you look at what they did and how they did their business, I wonder if there's another period in history when so much changed so rapidly as it did from what you say about the 60s
sometime in the 60s
to the 90s.
To the 90s, 30 years or so.
I don't know how you'd measure that.
I don't either. But
I don't know how you'd ever measure that. Product complexity, societal pressures, government pressures, they all happen at once. Bam-o. Were there maybe the other point in our history that would have been would have driven changes was maybe with the labor movement.
In the 30s.
Yeah, that's a
Yeah.
biggie.
Yeah.
That's a biggie. Today it's kind of still a big labor movement, but in a different direction,
Right.
fortunately.
Who's the best boss you had, Jim?
Best boss I ever had? Oh boy. I had a lot of good bosses. I only had one bad boss. Hated him. Hate to hate another human being, but I really did. Later on, he worked for me, and he said, "Are you willing to forget about some of the things I did to you when you worked for me?"
You turned it around on him, huh?
I said, "Of course I am." He was just a little man that was given too much authority. I had a lot of good bosses. I learned, I guess if I had to single out two people that I enjoyed working with the most, boss-wise, would have to be Frank Ball, who taught me so much, and Tom Leonard, also. When I was a real young pup, Tom he taught me a lot, and he worked for me for a while, and then I worked for him for a long time, and then he worked for me, and then we had equal jobs when the powertrain group was split up into 3 compartments, and he's still a good friend today. In fact, last fall, and it's still in the carpenter business. I helped him refinish his basement. We used to talk about old times. But I think those two guys, Stemple used to frustrate the dickens out of me at the time.
Yeah, we should talk about him a little bit.
And but he was, I really respected him and recognized that he was really going to go places, but he frustrated me and
Why
maybe.
did he do that?
Oh,
knowledge base or something?
No. He was always nice, and he was always listened, and he was a good boss. And I enjoyed working with Bob.
Mm-hmm.
But somehow he frustrated me, and I'm not sure why he frustrated me. I don't know. He sort of always ended up getting his way. And maybe that's because he was smarter than me. You know, in your rapport with a boss, if you don't agree on some things,
Mhm.
sometimes you get your way and sometimes the boss gets his way.
Mm-hmm.
You discuss it and argue about it, and out of that discussion, argument comes the truth, and you go in that direction. Sometimes it's yours, sometimes it's his. Somehow with Stemple, I never got my own way when I disagreed with him. And I guess maybe that's because he was a lot smarter than me, which he is.
May have been his knowledge base or something.
Yeah, but maybe that's, I don't know what, you know, Ellen said, oh, my wife said I was happy that Bob made, when he made president, when he made board of directors, I was happy. She says, why are you so happy? You used to complain about him all the time. I said, I did? She said, yeah. But you know, you always complain about your boss at home. He can be the greatest guy in the world, but you always complain about him. We had a lot of good bosses in that place. A few bad ones.
Yeah.
But, you know, I've told this to people, you know, young guys that worked for me that sometimes complained because their career wasn't advancing fast enough, and they were being, weren't given opportunities and all. I'd say, you know, I never knew anybody in Oldsmobile in a higher level job that didn't deserve to get that job, and that was true. And I don't know that maybe that's true. Is it true in every organization, or is everybody in every job eminently qualified and deserving of that job? I
don't think that's true.
I don't know of any cases in our organization where the guy in a given job wasn't eminently qualified
Mm-hmm.
and deserving of that job. I can't think of any examples.
Mm-hmm.
And I was trying to tell young people, if you have it, you'll get there. Because there's always a greater need for top talent than talent to pick from, even in a big company.
Mm-hmm.
I believe that. I saw that happen. You sit around in meetings trying to decide who ought to get this job.
Yeah.
And the pickings were slim.
Mm-hmm.
Not that we didn't have a lot of good people,
Yeah.
but there was always a greater demand than there was a supply.
Mm-hmm.
So you got good people there, and it was a good place to work. But it's getting tough nowadays again, too. You going to do anything in your book about what's the right word? The forces that drive the business now compared to the forces that drove the business, I'll say, up until...
Well, we're tending to cover those things as we travel along. The demands from the marketplace and the demands from, like, the union movement in the 30s and that sort of thing. Is that the kind of stuff you're talking about?
Well, it's almost, I guess what I'm asking is almost an industry-wide situation, as opposed to Oldsmobile, the HRM, the societal, the emissions, the fuel economy, the energy, the don't get your ass in court, and the lawsuits, the liabilities therein, and all that stuff that has
impact on how we do our business.
Yeah, you know, go back to what is an automobile? It's a thing that takes you from point A to point B.
Right.
That's all an automobile is, fundamentally. Why do you buy one? It's because you're at A and you want to go to B.
Mm-hmm.
Now, that simple goal evolves into the design of a thing you climb into, and you do that. It's got nothing to do with the fuel economy. emissions, the quality of work life, the equal opportunity, the keep your fanny out of court, employer reviews, up. All those things are aside from that fundamental objective, right?
That's true.
And they all, so now industry-wide, all those other needs hit a business where that need has nothing to do with why the business is there. Am I saying that right?
Yeah.
What do those things have to do with getting from A to B?
They don't really contribute to the objective.
Exactly. They're a burden, they run the price up and don't, probably necessary,
Yeah.
but not, okay, so at some point in our history, all those things started to hit.
Yeah, they sure do.
Not just Olds, but
No,
everybody.
everybody in the world.
Yeah.
Well, we'll try and cover those things as best we can. Well, what have we left out that we should talk about? Anything there?
Well, I went on to reliability and then manager reliability and testing. There's just nothing there.
Reliability and test.
There's nothing there that's the dumbest job I ever had.
Why was it a dumb job?
Well, there's nothing we did that had to be done. Now, that hits right into what I was saying.
Right. Why are we doing that then?
Beats the hell out of me. Somebody decided we were going to have a reliability department. Quality needed to be improved way back.
Yeah, this was a long time ago.
Well, it wasn't too long ago when the reliability started. Who was the first guy that headed it up? Truxell. You know, your product needs to improve reliability.
Maybe it was Dart.
I think you're right, Jim.
Dart, I think, yeah.
If you need to improve the reliability of your product, you don't do that by creating another department. And the only thing that department did, now I'm talking about reliable, I'm not talking about the inspectors,
Yeah, that's a different subject. Yeah.
the Bud Bartell part of it, or the audit. The only thing that I did with my little group of people there was I audited emissions over there in the factory garage at that emission facility. And that had to be done by law. But everything else we didn't have to be done. We were supposed to engineer reliability. Well, how do you do that if you can't control the design? And nothing to say about the design, nothing to say about the manufacturing. How do you enhance reliability if you can't? So it's a frustrating job. Couldn't wait to get out of that job. Frustrating.
Is that because you couldn't accomplish anything, or
Well, what is the objective? Gee, we spent hours in meetings with the guys. What is we're supposed to do, guys? Nobody knew. If your job is to improve reliability, how do you do that? Well, you see a problem in the field and you get the information on how you might solve it to some engineer who may or may not heed your advice and make a change. But that's after the fact. The product's already out there and it's already deemed unreliable.
Right.
See? And we had nothing to do with proof testing prior to production. Now, when I went back to product engineering, I was manager of reliability and test, which used to be called the experimental engineer, which headed up all the testing in the facilities and the labs and or the building and the prototypes. So the word reliability was thrown into that, so that in that upfront testing, we could approach that in a manner consistent with improving reliability before the car went into production.
So you're backing upstream away.
Yeah. So at that point, my department had some substantial ability to be a part of improved reliability. But over in the reliability department, didn't have anything to do with reliability.
When were you in the reliability department?
From 80, 1 to 84. Is there 3 years?
Yeah. About 3 years.
And the first year I had a ball, I was trying to figure out what it is we were supposed to do. That was kind of fun.
Okay.
Because Dick McKay said to me the first day, I had about 2 hours with Moncaba,
Uh-huh.
who had the job before me. And he couldn't tell me much about what we were supposed to do, so we tried to figure it out ourselves, my gang and I, Bob Mel and Roger Harris and Joe Pohl and some of the other guys, and Ralph Smith. And trying to figure out what it is we were supposed to do. And one day it hit me. There isn't anything we do that has to be done. And I'm going back to what I was saying before. You're trying to go from A to B,
Yeah,
fundamentally. We didn't have anything to do with that. And we were like one of those burden groups, you know, like the QWL activities and the emissions, and that's maybe a little different because we had to do that for society, but that was a silly job. Well, that department has since disappeared, you know.
Gone away.
Now, what's it tell you?
I don't know.
It tells you it didn't have to be.
Tells you something, though.
It's gone. They changed the name to Product Assurance. That doesn't change anything.
Yeah.
And so what's that change? Yeah, that was kind of I don't know who had the idea to create that department, but it wasn't a very good one. And I was happy to get out of there. I really didn't like it.
Mm-hmm.
The only thing I liked about that job was I had my very own secretary, mine and mine alone. And she didn't have anything to do. She'd clean my desk off and straighten my ashtray, clean my ashtray, and I just thought that was great. Silly.
Who the heck was the boss when you were there?
Well, I had 3 different bosses.
Oh, my God.
Dick Vickeyes, when I went over there. Oh, yeah, I started to say about Moncaba.
Yeah.
When I was in the office first day, Dick Vickeyes came in and said, you know, I don't have the slightest idea what Moncaba did, but as far as I'm concerned, you can keep on doing what he did. And I said, I don't know what he did either. Not very much. Well, he said, do whatever you think ought to be done. He left, and that's it.
That was your direction.
That was my direction.
Uh-huh.
Okay, then he left, and Bob Eaton came in. He was only there just a short stay. And then he left, and Harry Lyon came in.
Mm-hmm.
My old buddy Harry.
Mm-hmm.
We've been friends for years. It was just those 3.
Mm-hmm. 3 guys in 3 years wasn't bad.
Yeah.
Okay, then where you ended up back in product then?
Yeah, then I went back to product for
Okay.
2 years before I retired, and from 84 to 86.
Okay,
And I was manager of reliability and test.
okay.
I had 3 bosses then, too.
You had 3 more bosses.
Yeah, that was a little frustrating. I liked that job.
See, who were those guys?
Well, in the reorganization, reliability and test was a central organization.
Right.
Harry Lyon was headed that up, and then there was somebody at each site.
divisional site.
Yeah, and then somebody at the proving grounds, and somebody at Fisher, the body facility. And by the chart, I worked for Harry.
Mm-hmm.
But I didn't see Harry very much, didn't talk to him very much.
Oh,
I had to satisfy the needs of the chief engineer of the platform, and I had to satisfy the needs of the chief engineer of the powertrain. So I had 3 people tell me what they thought I ought to be doing.
mm-hmm.
And that got very frustrating. And I had a terrific staff. Boy, I had the best staff I ever had in my life. I had 5 guys working for me that were 8th levels who just were very good people. And it sort of evolved into where the guy that headed up the platform testing, he was in the chief engineer's pocket. And the guy that headed up powertrain testing was in the powertrain chief engineer's pocket.
So you sort of assigned guys to...
And they ended up really working with those guys more than I did,
Mm-hmm.
because I had to worry about the shops and Harry and HRM and budget and all those things.
Yeah.
That the way I set that up was so successful that a year after I retired, my job went away.
Oh, you got rid of yourself.
Yep, I got rid of myself. They went, I think it went about 6 months after I left before they even put anybody in my job. And then somebody went in there, and just a few months after that, the job went away. I would have been offered retirement instead of retiring voluntarily. But I was kind of proud of that, the way that problem of having 3 bosses and the way I handled it turned out to work pretty good. If the job can go away and you're not needed, save a lot of money. Yeah. But you know, those were not the exciting years. Reliability was not exciting years. The reliability test, it was not exciting years. At least, maybe I was getting too old and too good at what I did to be excited about anything anymore. They weren't as exciting as the mission days. Exciting, frustrating. Or the best job I ever had was a fuel tank. Boy, that was glory. Fuel tank business, that was just super. Because nobody had ever done this before, and we didn't have any idea how to do it. We figured it out. It was fun. Worked closely with Stemple then. And before I was exciting days, fun. That one went away. So I don't know what all that gives you for your history book, but
Gives us a lot of background.
that's the gospel according to Jim Benner.
That's the gospel.
Whatever.
Okay. Anything else you want to talk about?
No, I gave this quite a lot of thought, you know, in idle moments, since you called me a couple weeks ago or last week, or everything. Well, what can I contribute that might be of some significance or some contribution to your book? And I still don't know what the answer to that is, but then I did try to think about
Well, I think that's fine.
some of the more significant
Obviously areas
things.
there
And,
that nobody else will talk about. So
yeah,
it's good.
a little sentence from this guy and a little sentence from that guy,
Well,
and
it's a good,
you can make a book out of it.
it's a good coverage. Good coverage. I think people will stand back 50 years from now and chuckle about all of the headaches we went through
Yeah.
to get from here to there. So, well,
Why don't, do you have an address here? Of course you do.
oh, sure, I'll give you a card when we get done.
And
How's that?
why don't I take that picture out of the frame and mail it to you?